When evaluating a diagnostic test, it makes sense to want to know whether or not the result of the test will change the probability that the patient actually has that particular condition. If, for instance, a positive or negative test result really doesn't change the probability that a patient has a disease, it's probably a test not worth getting. So knowing all this, it brings us to our likelihood ratio. Now the likelihood ratio for a positive test result takes the number of people with the disease who have a positive test result. This is also known as the sensitivity, and it divides this by the number of people without disease who get a positive test result, or 1 minus the specificity. Another way to look at this is it's equal to the true positive rate divided by the false positive rate. Now, the likelihood ratio for a negative test result is the number of people without disease who receive a negative test result, or 1 minus the sensitivity, divided by the number of people who don't have the disease and got a negative test result, or the specificity. This again is also equal to the false negative rate divided by the true negative rate. Now, if the likelihood ratio is greater than 1, this increases the likelihood that the disease in question is present. While if the likelihood ratio is less than 1, this decreases the likelihood that the disease in question is present. And this can be divided out into a table as follows. Here you can see that with a likelihood ratio of 1, there's no change in disease probability. But as the number increases or decreases from 1, you can see that the probability of disease changes. And if you look at the extremes of the spectrum, if you have a likelihood ratio of 10, this gives you a 45% chance increase in the probability of disease. While if you have a likelihood ratio of 0.1, this decreases your chance of disease by 45%. So with all that, what do you need to know for test day? Well, likelihood ratio questions are often presented to you in forms of probability. Here is an example of what I mean. So you think you have a patient that has lung cancer, and you're told that you have a new test that has a positive likelihood ratio of 10 for the diagnosis of lung cancer if it is positive. You have your patient tested, and the test is sadly positive. And here, the question tells you that the patient had a pre-test probability of lung cancer of 5%. And they ask, what is the new probability of lung cancer? There you go. You've got it. It's 50%. Here, as we just stated, you had a pre-test probability of 5%, and you had a positive likelihood ratio of 10 if you had a positive test. Again, this patient had a positive test result, so this results in a 45% increase in his probability of disease. Now, most physicians actually don't use this on a day-to-day basis, but it is important to know for your test, as well as a part of evidence-based approach to medicine.